Good morning. This is Michael Dong on episode number 10. Why is it okay to use a mobile phase pH close to the analyte's pKa? Scope. Why avoid using a mobile phase pH near the analyte's pKa? Now, we were all told quite often by many people to avoid using a mobile phase A pH near the pKa of the main analyte because a split peak may result from the ionized and the non-ionized form of the analytes. I'm very skeptical of this statement because I have not seen any evidence of such peak split or peak abnormalities. I'd like to enumerate the reason why split peaks are not observed. First, the hydrophobicity of the ionized state and the non-ionized molecules are disparate because one is an ion, the other one is a non-ionized neutral molecules. Since most small molecule drugs are basic, uh, typically the ion is a protonated form ion, and the free base of the drug will have very disparate or very different retention factor or K. I've shown here a case study on the separation of two bases, which are antidepressant, amitriptyline and nortriptyline. This is figures courtesy of Waters Corporation, where we do isocratic separation under the same solvent strength of the same level of mobile phase B, acetonitrile and methanol, but varying the pH. Uh, Now, the retention is going to be very low acidic pH because these will be ionic, will be protonated, therefore very water soluble, while under high pH, near the pKa, they will be non-ionized and therefore have very much higher retention factor or retention times. You've looked at data. The pKa of amitriptyline is, which is a primary amine, is 9.45. The K or K prime at pH under 6 is like zero point 0.2, it's almost like not retained, very near the solvent front. However, the K is actually over 30 at pH 9. So the hydrophobicity of the ionized and non-ionized are very disparate, very different, and it will not be split, right? You will not be able to have a split peak. It's going to be like night and day retention time. Also, we don't observe any evidence of split peaks at uh, page 8 to 10. You can see the peaks remain pretty sharp peaks with no evidence of shoulder or split. The other consideration is the fact that the ionization event occurs instantaneously. Ionization event in solution occurs in nanoseconds or under nanoseconds. So the separation of the two forms by HPLC will really not be truly possible due to the very rapid or instantaneous equilibration. Now, this is in sharp contrast to other form of conversions, such as the separation of syn and anti-rotamer from restrictor rotations, because the conversion half-life is actually in thousands of seconds. Second example are the tautomers from the keto and eno form, and some of these are very stable with half-life ranging from minutes to hours. So split peaks or the resolution of these two forms are possible if the conversion rate is slower, uh, but really not possible if the ionization is so almost instantaneously. This is a case study of a high pH separation of a drug product with two APIs. So we are examining an actual case study of a stability indicating method using high pH mobile phases for a drug product with two opioids. One of the opioids is an agonist, a painkiller, and the other one is a antagonist, which is sequester. So it's a anti-abuse kind of drug product combo being developed. Now here the optimum pH was found to be having a pH optimized very near the pKa of the two molecules, two analytes. Here is the actual separation using a retention marker solution containing the two APIs. One is the opioid agonist, the other one is an antagonist, and their respective process impurity and degradation product shown here. So it's a very complex separation. Obviously, using high pH, you need a special column which is high pH compatible. So here is operating a condition in this optimized method using a Waters Xterra MSC18 phase, which is a hybrid with this dimension. And the final mobile phase pH is a buffer at pH 9.1 and shown under these grading conditions. So 3% acetonitrile to 50% acetonitrile. I'd like to point out that the pKa of the primary API, the first one is 8.8, and the second one, B, is 9.3. And the optimized pH that we found was actually at 9.1. And there's no evidence of any split peaks observed from these two ones. So this is actually a good strategy for very soluble basic drugs, such as morphines or opioids, which are very stable at high pH. And if one try to do it under acidic condition, there's no retention, so you have to do ion pairing, which is absolutely not very good. And the high pH separation would be a very viable, which is also mass spec compatible. So these are published in Journal Chromatography A in 2003. Shown here is the retention map under grading condition. The retention using the pH optimization of the method. One can see that the optimum pH is where there's almost baseline resolution is at 9.1. Now, since a slight change of pH can actually affect the retention quite substantially, when you operate your pH near the pKa in the sloping part of that curve, the pH fine-tuning is actually very effective, meaning it's a strong factor. However, there's a big issue of method robustness that we experience on that. So here's the pros and cons of working near the pKa is not split peak. It's actually a robustness issue. In summary, a split peak from working at mobile phase pH near the pKa of the analyte is a myth. It's actually possible, and it's actually desirable because it's a strong fine-tuning factor in optimizing the separation. And the two arguments that we raise are the fact that the hydrophobicity of the two forms are quite different, quite disparate, and also the fact the ionization events almost instantaneously. So it really is not possible to have split peaks. And number three, we show a high pH separation of two water-soluble basic drug, two opioid near the pKa of the analyte. And actually, this is an effective strategy if one can accurately adjust the mobile phase pH to plus or minus a 0.05 pH unit, which is possible with a pH meter and electrode pair with ATC, standing for automatic temperature control. So it is, even though it's not robust, it's possible to operate under those conditions. Here are some references. Chapter 10 of the book, two white papers, uh, one white paper published in 2018, and actually one technical paper in Journal of Chromatography on high pH separation under ICH impurity analysis. And also a YouTube channel, episode number 4 and 5. This is the end of episode 7. I'd like to thank you for your attention, where we discuss using mobile phase pH, need to analyze pK, which does not produce split peaks. However, there's a method robustness issue which need to be maintained using a very accurate pH measurement of the buffers, uh, using automatic temperature control of the pH measurement. On that note, I encourage you to subscribe for the channel, and we see you next time.